I think this one works better than this. No echo. There's a PhD student give me a few backup things. Let me see. What is the name of the PhD student? Jahan, I think. Jahan, are you around? Let me check the email. Oh, Wenhan, not Jahan. Wenhan, are you here? Okay, I'll text him later on. He's supposed to give me a few backup. Nothing to do with the quiz, so don't worry too much. Yeah, it's more of a help me going around to be a quiz invigilators. Okay? You know, now the option is given to you, sir. Which part of the lecture notes do you want me to help you to do a reviews? The key important points actually are published on the canvas, right? I think a few weeks ago, before Chinese New Year, I get a good skeleton of the key points. Maybe I explain to you maybe the key exam formats. There are 25 questions. That's why you guys know, right? Majority of them are MCQs. There are a few true and false type of questions. True and false, there can only be one correct answer. It cannot be both true and false, right? Doesn't make sense. MCQ, a good portion of them are rarely multiple choice. Means the correct answer is more than one. That's why they call MCQ, right? Yeah. Multiple choice. And you may wonder to say, hey, sir, if there are 4 correct answers, if I only select 3 of them, do I get 0 or do I get something? By now, you're working with me for nearly 6 weeks, right? Collect 6 data points. What would you, if you are being asked to predict, what do you think is the possible outcomes? Do you get some marks or do you get 0 marks? This is a prediction or this is a wish? Predictions are, okay, you're right. You'll get something, you'll get some partial credits, not zeros. Yeah, and as I mentioned earlier, for those of you, if you manage to get a full marks, my promise still hold. I guess some of you probably doesn't really remember what I said, right? It's okay, yeah. Any volunteers? Which part of the lectures do you want me to go through with you? But don't say, hey, sir, the part which you said the quiz are. All chapters essentially have a question, have a quiz question to cover. Or maybe we do by steps, right? I go into the canvas, get out the key steps and key points. We do one by one, right? Or maybe I use that as a baseline to ask you questions. If you don't know, you better ask questions. Because this is the last chance for you to know before the quiz. Okay? Let me log in there. And by the way, after the quiz, for those of you who wrote a few emails to me to query and consult me on the projects, you're very much welcome come to here, right? I think I won't leave after the quiz, right? If you need my times, let's chat about your project progress. Okay. I think the CAP, the distributed system basics are there, right? We can probably talk a bit more today, just in case some of you missed the lectures. I know, right? I think right after Chinese New Year periods, I think there's a Saturday makeup lectures. The attendance only 25, yeah. So I hope all of you still manage to be able to review the recordings. If you don't, I can tell you it's a big loss for you, lah. Okay? All right. What is data engineering? What is data engineering? You still very much recall at the first lectures, we talk about quite a few key steps, right? So what is the data engineering? Anybody can help to do a quick recap. This is an important one. Nobody all fail 0 marks, okay. Any volunteers?
Building scalable and reliable systems that enable data ingestion to and processing in a way that it is consumable like downstream.
Okay, that's the definition, right? But if you want to decompose the data engineer in 6 parts, what will be the?
Data generation and raw data storage, then movement of data, transformation of data, and curated data storage, and analytics to like data consumption.
All agree? Let me randomly pick up some of you, right? You repeat what are the 6 steps. Later you will know why I ask you these questions. By the way, this is not to cheat. I think this is merely trying to recap the key concepts of data engineering. I also do not know whether you guys have enough time to do the hands-on, right? If later on I notice some of the programming questions I put inside the quiz, all of you fail. In lecture 7, 8, I'm prepared to spend some time to do hands-on together with you, so you can't run away from me. Yiwei, are you around? What are the 6 steps of data engineering? Unsure? Huh? You have to check your notes, lah. You better check quickly, okay? Yeah. All right. Zimeng? Yes. What are the 6 steps? Oh, by the way, on the actual quiz, you guys are not allowed to browse the forms. If you've been caught, serious issues. Okay, Zimeng, yes. Data what? Data collections? Raw data storage? Data transformations? Data storage? Data consumptions. But the first step is you can see data collection or data generations. Yeah, thank you, Zimeng. All right, I think that's, let's go to second point. Yes? Oh, it's not on, okay. Let me see how to get it on. Display here, they say on. Let me text the PhD students to see where he is, okay? Can you see now? Okay, these are the 6 steps of data engineering. From generations, to raw data storage, to movement of the data, to do transformation, to do storage again. But in this case, you are storing the curated data set. And the last one is actually consumptions. Shh, shh, shh. Don't worry. This is the time you guys should cherish the most, huh? Okay? So if I want to bring a new concept, sorry, now it's an old concept. Yeah. OLTP and OLAP. Where should it land? Across the 6 steps, where do I do OLTP and where do I do OLAP? Think and guess. And what's the difference between OLTP and OLAP? Or in the first place, what is OLTP? What is OLAP? OLTP stands for Online Transaction Processing. And typically, where does it stay? Towards the tail end of the engineering life cycle or towards the beginning part? Beginning part, right? Because you're closer to where the data is generated. And OLTP typically store raw data. Not say you can't store processed data, but typically store raw data. Why? Why you want to use OLTP to store the raw data? Why you don't want to do some further curation, clean the data, transform the data? Why? You want to do it fast. If you want to do analysis that is not time critical, you do it later. OLTP typically close to the production systems. And for 40B to production system, you want the transaction to happen fast. You want the information to store consistently, reliably. But now, if I need to do analysis, it will be OLAP. Where do I look for OLAP? Towards the tail end, right? I store for curated information. Okay, we spend time to talk about raw data storage, right? OLTP. Do I share with you guys the details, right? What kind of databases do we typically use for OLTP? 3NF? What does 3NF stands for? If you don't know, Google now, because later on the internet will be lost. Yes. So there are 3 things, right? What's the first things? You know this, right? But how about the rest? If you don't, open your lecture notes now. Identify where to find this information. I will slow down, right? I'll slow down. All of you get it? What does 3NF stands for? And what's the difference between the primary key and foreign keys? How do I do joins? And why do I need to do joins? I say, this is not to see something to make you stress, if you do not know, right? I'll slow down, spend some time to check your lecture notes, and raise your hands. Thank you very much. You'll stay here or you will be leaving? I'll be here. Throughout the sessions. Yeah. Thank you very much. Thank you. Feel free to choose any seat you want. These are the seniors. He's currently as a PhD student. Yeah. All of you get answers? All of you know how to find the information? Let me open a new page, right? I'll randomly pick up some of you, right? If all of you got starters, don't know how to answer, I seriously worry later on that how you're going to pass through the exams. I'm not aiming for somebody with the full marks. I'm aiming for a good portion of the students cohort passing the quiz. I can't change the question anyway, it's been set. This is the observer. I can't. Pambo, are you around? Yes. Maybe share a bit more, right? What's the difference between the primary key and the foreign keys? And how do I use them to join the tables together? This is a simple one, right? Okay. How about you check now? Later I'll come back to you. Anybody who can answer that questions? Junwen. What's the difference between the primary key and the foreign keys? And how do I use this information to join the tables together? Mm-hmm. Unique identifiers, right? Unique identifiers, okay? Okay, don't worry too much about the definition, right? How am I going to use the primary key and foreign key to join the tables together? You can use the illustration of different type of joins to explain that. How many type of joins are there? Yeah, and I suppose all of you know the difference between the left, right, and inner joins. Okay, if you do not know, quickly browse the notes or do a quick Google, right? All right, data movement, I think unfortunately we didn't have much time to discuss, so I think you will not be covering the current quiz. But next lectures we'll spend some time to talk about streamings. Let's literally talk about how to move data in real times. All the while, I think the data discussion here essentially will talk about data by batches, right? Even the distributed so-called systems we discussed, I think, during the Chinese New Year periods are predominantly, I think, what we discuss are moving the data by batches. We never talk about real times. We didn't even discuss in message queue, right? So next week, we're going to spend some time to talk about that. But this will not be included in today's quiz, right? We're not going to discuss about real time. So you guys are not going to be tested as well. Transformations. What have we discussed? How do we transform the data? In fact, I think we discussed nearly, 1.5 lectures. Of course, not the entire lectures, right? Talk about transformations. I give it examples. I literally provide the Python code as well. Give me a few examples. How do we transform the data? Yeah. Remove duplicates. That's one type of transformations. What else? Aggregations. What else? How about imputations? Imputation means, first of all, you identify the non-records, right? And if the records are super important, just because one column is empty doesn't mean that you should throw them away. And you want to find a way to fill in the gap. Typically use a mean or median values. And how do we do it? Use the Pythons. I think an example has been given in the lecture notes, right? I do not know you guys have the time to do a hands-on or not. That's why I say, after today's quiz, I'll check on the result and progress. If need to be, let's spend some time to do hands-on in the lecture itself. Typically, I don't do that, but I do want to change the pace a little bit to make sure after graduation from this course, you guys really learn, not just listen. Curated data storage, I think we briefly mentioned about it. We didn't go into details, right? So we didn't share with you how do you build, end-to-end data marts. But we did talk about various different ways to organize the informations. For example, star schema. right? You guys know what is star schema? I want to do a sampling again, right? Let me see. Yeah. Yes, what is star schema? You don't need to go explain the definition. You can even give example. You can even come here to draw also can. Whichever way you prefer. Okay. Sales amount, right? Okay. Not bad, yeah. Yeah. Did you have any prior experiences or essentially you pick up this through these lectures? Have you used the star schema before? Okay. Okay. I want to go one layer deeper, right? Sorry, not to make your life difficult. Why do we need to have star schema? What's the benefits to have star schema? Why I can't use the conventional SQL approach? I do multiple joins together. So you don't do a multiple nested inner join together, right? Join is very expensive operations, whereas star schema at the facts table in the middle have multiple dimension surroundings. You just need to do one join with the dimension you want. Faster, two joins or one joins. Yeah, but star schema is star schema. The data inside the star schema is normalized. In order for you to answer, you have to understand what normalized mean, right? That's the reason just now we talk about 3DF. Is star schema not to post you right? You did a very good job. Thank you, Yaya, right? Is star schema or normalized data schema or not? Yes or no? And why it is not no? Sorry, I shouldn't see why it's not no. I think I don't want to give a tough time. If it's no, how do you make it normalized? If it's bridge the 3DF, means you do extra things, right? Then how do you make it normalize? Decompose one table into multiple different tables, right? When you do normalize means that your data is a layman terms. When your table is not normalized, typically see that you push too many things all together, right? Your table may have redundant columns. You merge multiple attributes into one column. Means you need to decompose your table to multiple smaller tables so the data will be normalized. That also means that the star will need to be sent into snowflakes. I didn't go for I think in the lecture only talk about that too. I know if you guys don't do hands-on, frankly speaking, it might be difficult for you to appreciate unless I keep on talking. Just like a Chinese kung fu, I keep on talking about this kick and that punch, right? You guys never got a chance to practice. It might be difficult. So snowflakes is normalized. And just now I'm saying that, hey, star schema is good for people to use for faster turnaround time. You don't need to do multiple joins. Why suddenly we want to turn into snowflakes? Are we dropping away the benefits we're getting from star schema? Think about this, right? You guys still have 40 minutes to figure out some sort of answers. Okay, yeah? And for star schema as snowflakes, on these spectrons, typically where does it land? Here or here? Here are OLAP. You organize the information in a nice format for what? Not to say not to play around, for you to produce the report, for you to do the analytics conveniently and quickly. You organize the data set. Whereas here is a bit more raw. You produce as it is, you don't do too many organization of the data elements. Okay? I think We spent enough time talk about OLTP and OLAP, right? Acid properties. The answer is here, but I do want to get a bit more deeper understanding from you. Explain A. What is A? What is A? And why do we need A? A is atomicities, all or nothings. Why do we need A? Why do we need all or nothing? Just don't ask you. If you choose, if the correct questions have 4 answers, you guys only choose 3, right? Did I give you guys A, all or nothing? Why partial is something great? Why here you can't do partial? Create distress.
Distrust in the system. For example, if you do partial updates for transactions, you updated the debit information but not the credit information in the other account.
It causes problem, right? For you to insert a record into the database, you got to do it properly. You can't do it partially. It will cause the downstream problems. If a customer's bank account got debited for $100, but later the beneficiary, the receiving party didn't receive anything, that will be a problem. The more ideal situation is that you just reverse every single thing, right? So this is different from the quiz, huh? How about consistency? Consistency. Why do we need consistencies? If today I query your quiz result, out of 25 marks, I think it's showing 24. Tomorrow I query, it becomes 14. Sorry, 14 doesn't seem to be nice. Become 25. This database is not very reliable, right? Same query need to return me the same result. I don't want a non-deterministic databases. And talk about that. Will all the databases return me a consistent result or not? Will all the databases give me, no matter when I query, assuming underlying data set doesn't change, right? I query today and compare to a query tomorrow. Would I always get the same result, consistent result? The answer is no. I think during the Chinese New Year period, the makeup lectures will talk about. For distributed systems, it's a trade-off between what? You still recall CAP, It's not your CAPS, okay? Your GPA. C stands for consistency. A stands for availabilities. For distributed systems, it's a trade-off between the two. People will say, hey, sir, how come you never mentioned about P? By definition, you talk about distributed system, the P is a given. Right? Partitions. Then people say, hey, talk about SQL databases, sir, how come you never talk about availabilities and the trade-off between availability and consistencies? Because in general, for most of the SQL databases, it's not distributed. It can't, I don't mean that SQL cannot be distributed. It can, right? For some of the cloud systems, if you go there, you can see there are options for you to choose to have a distributed SQL databases. And when you do that, then CAP will start to kick in. Isolations. These are interesting ones. Anyone want to explain a bit more on the isolations? What does the isolation stand for? If I do a queries on Tanya's exam result, Tanya got 24 out of 25, not full marks, I got upset. Then I check Sumita's one. Never mind, I don't want to check, right? So one transaction shouldn't interfere the other transactions. There's no dependencies. Durability, I think this one without going to see, right? We're talking about database. We're not talking about a RAM, right? You need to make sure the database store the information there permanently. Not you switch on the electricity, all the data inside is gone, right? That's called RAM. Does all the database have the ACID properties? No, lah. Obviously no. Why? Why? Write down those questions if you cannot answer. I mean, it doesn't mean you appear in a quiz, because some of the questions I asked is slightly deeper than the contents are said inside the quiz. But it might be beneficial for you in future if you need to think deeper and going further on the data engineering track. I think database design, just now I think I spent some time to talk about it as well. What does ER model stands for? I'll slow down a bit. Go browse your notes. What does ER model stands for? And why do we need this? Give you 1 minute. Then I'm seeking for volunteers to share. You bring your laptops, right? Oh, okay. Anyone want to volunteer? ER stands for entity relationships. Why do we need to describe the relationship across different data sets? Why we can't let the user figure them out by read through all the script? In one of the lectures, in fact, in the lectures when we talk about the stock trading strategies, right? I think we share with you the notebook. In fact, if user spend all the time to read through the code, he or she will know exactly how to use the data set. Why we need to build ER diagrams on all the key data set? The reason is because not everybody have the enough time to read through the code, and not everybody who need to use the data set will have the Python knowledge to understand every single line of your script. In fact, he doesn't need to know. He just need to know what are the key attributes of the data set and how those key attributes are linked to each other through primary key and foreign keys. So that by looking at the ER diagrams, he roughly know how to retrieve the attributes he or she need for their reporting purpose or downstream analytic purpose without going through every single line of the Python script. So in your projects, hopefully, right, if your data set is complicated or sophisticated enough, you may want to produce a ER diagrams so that when I review that, it's much easier for me. I don't need to guess. And sometimes, you know, I guess it 1 time, 2 times, I don't have that. I assume you don't have. Okay? Normalization, 1.5, 2.5, and 3.5. What is 1.5? It's in the notes. Go check it out. 30 seconds, then I'll randomly choose somebody to answer this. Otherwise, I keep on going back to Tanya, Sumita, or Wei. Wei? Oh, you're here. Don't worry, I'm not asking you, right? You're one of my go-to person to ask the questions, but not for today. 30 seconds, huh? Okay. Zishan, are you around? Zishan? Sure, of course, you can. Do you mind to speak a bit louder? Okay. Give me an example. How does the each field can contain more than one values? More than one hobbies, right? Okay. Yeah, and the example I gave it to you guys earlier on is to have the student's name and matriculation numbers being put in the one single cell, right? So that probably should be separated in different columns. Yeah, the example you give, the students have more than one hobby. I love to do programming. I love to do sports games. You put them together in one single cell, separated by comma. Ideally, it perhaps should be inserted as an independent row, not in the same columns, right? So how about 2NF? Okay, do you understand what that see? Do you understand the definition of 2NF? I know that you read out, but you don't understand this, right? No, if you don't understand, it's fine. Wow, right? Yeah. Okay, I accept that as an answer as well. Yeah. Okay. Then 3NF. Okay, it's layer after layers, right? So you guys make sure that you know where to find this information, right? And hopefully that you spend enough prior efforts to understand what does it mean now, right? Otherwise, it's a little bit too late. But thank you very much, Zhe-san. Yeah. Come back to here. Beyond relational databases. We didn't spend too much effort to talk about this in details, right? So for graph, I think I'm probably going to spend half a lecture, maybe one lecture to talk about this, because in FYs, nowadays got more and more people use the graph databases to do anti-money laundries. It's a very nice way to organize the information and use the graph theory to figure out nice attribute to fill into your machine learning algorithms, right? So potentially we're going to spend one time, maybe half a lecture, one lectures, to discuss this database in details. Yeah. Time series. We briefly mentioned about this, right? Why people need to store time series information? What are the use cases? Or what are the scenarios? Do we need to put data into a time series databases? Why can't we store the information in a traditional SQL databases? You can, of course. Nobody can stop you there. You can do it. Mm-hmm.
For example, for credit score rating, you might want to look at like what this person's previous credit score was and when it changed.
Mm-hmm.
You do need like time.
You need to have a timestamps, right? Yeah. Any other examples of typical time series data? Stock informations, right? The price, high, low, open, and close. The candle chart we discussed earlier on, right? Each of them need to have a timestamps. And across hours, across minutes, across days, you have all this information. And typically, people does not modify this information. So by organize this information in time series manner, store in a time series databases, there are a few of them. For example, Prometheus is one of them, right? The query them is much more efficient compared to you do it the same way from SQL databases. Not say you can't store the information in SQL database, you can, right? Just one column is the timestamp. The other column will be the price high, price low. In fact, in the stock trading algorithm, example we give it to you, We store all this information in a Python data frames, right? You can treat that, I think, as SQL databases. Not exactly the same, but similar, right? Nothing wrong with that. Document store. I didn't discuss things enough, not details enough. Key values. I think we very briefly mentioned Redis, right? For speed, quick queries. It's like your Excel VLOOKUPs, but happening in RAMs. Columnar. That one I think we spent a fair bit amount of time to discuss. The traditional SQL databases are very much role-based. The information across different rows are stored together. Even if you have a very sparse databases, means there are many columns inside the values are empty. But somehow you are still occupy the storage space. But if you store the information by columns, you can save, you can optimize the storage space. Of course, the query, the way you query then will be different as well, right? I don't want to turn this as a lecture. It's supposed to be a quick recap, right? If you're unsure, I'll try to finish the review earlier, so that for those of you, right, if the key concepts I mentioned just now, if you have a blind spot, you still have 20 to 30 minutes to do quick reviews. Ask GPT quickly to give you the answers, right? If it's taking too much time for you to find the relevant portions in the lecture notes. Okay? Dimensional modeling, I think we discussed. I think the star schema. Oh, actually I put it here, huh? Then snowflakes. All right? That's the favorite topic. ETL. What is ETL? Why do we need to do ETL? What does ETL stands for? Extractions, transformations, and loadings. What is ELT? The same thing, but in different sequence. Why do we want to do things in different sequence? Should I do transformation first, then load the curated information so that I don't need to deal with the dirty, polluted, contaminated data later on? In what? In some? Taking too much time. Taking too much time, right? So in these scenarios, you may want to load the data, the raw data first. And whoever wants to use them later on, you do your own curations. So in modern data lake architectures, ELT is used more often than ETLs. Did I share with you guys, I think, how does the modern data lake look like? Do a quick recap, huh? You mirror or duplicate all the data assets from all your production systems into a common place called data lake. If you have 1,000 production systems, each of them have 100 tables, then you duplicate that 100,000 tables into your data lake. That's the base, the primary tiers. Afterwards, you may want to aggregate those raw data sets, curate them into something called a data warehouse, do the necessary transformations and aggregations. And subsequently, you can do anything, right, based on the data warehouse to build your reports, to do your downstream analytics. So you load the first, then you do transformation later. Okay? Talk about data lake, since it's a data engineering as well, right? When you put too much data in the data lake, what are the potential drawbacks? When you put too much data into your data lake, what are the things you need to put into considerations? Just like when I have too many students, I mean, have 90 each of you is fine, right? But when I have 900 of you, what do I need to take care of? First of all, I need to know who you are, right? Your names, the metadata, a description about you become very critical. Otherwise, I do not know what the data sitting inside the data lake, or who are the students sitting in the lectures. But unfortunately, we're dealing with hundreds, thousands of tables, sometimes millions of tables. That metadata, the description about the data sets, are not always properly maintained. When that accumulates, your data lake may become something called a data swamp. Right? It's big. It contains a lot of data. You can get in, but it's difficult for you to get out. Means that it's difficult for you to find out the data set really you need, because simply there are too many and lack of descriptions. You get inside like you go into a library, but there's no catalog. You keep on browse every single book, you can't find the book you need, unless you have a proper way to organize them by alphabetic orders, by authors, by themes. Data transformations. This one, I think I need to open the notes, right? There are some programming techniques we do want to make sure. How many of you essentially have tried the code I think I put in the lecture notes? Raise your hand, please. It's okay if you're not done, it's fine. Wen Yi, Tanya? Only a few of you, okay. Okay, never mind. Later on you will see, right? Yeah. Let me open this. This should be lecture what? Should be this. Not this one. Can you guys see this clearly or not? It's too small. Let me go to the key functions, just do a very quick recap. Yeah, the login I think means that thing is a good practice. So every time you write the code, you make sure that you add in the log, and also trying to do section handlings, right? That's a good practice. Let me go to this. This is talk about how to read the data from files. Read CSV, this is a given, right? You guys know how to do it. How to read data dumps, like ParQs and some other SQL data dumps, right? Come to data dumps. You guys now know why do we need to figure a way to read the data dumps? Or in the first place, why do we need to save the data into a data dumps? A data dumps means it's an interim data set I want to store as an object. Why do we need to find a way to save the interim results into a data object? To have a warm start. Yeah, what is a warm start? Anybody? What is a warm start? Just now I mentioned, right? For a database to be consistent, every single time I need to query that, I should give the same result. Why do I need to store, if I need to do some data processing, why do I need to store the intermediate result? I can rerun the script again, right? So I can get always the same results. Why do I need to save the interim results somewhere? What's the point? It might take very long, right? The example I'll give you to guys earlier on. Sometimes you're dealing with millions or billions of records. For you to produce something, for example, right? It may take 6 hours, 1 day. And if you don't save the interim result somewhere, you need to take another 6 hours or 1 day to arrive at the same state. Why not just save the interim result? I start from there. It's called warm start. The other one, restart we start from scratch again, it's called cold start because you have nothing to begin with, right? You start from scratch. So when you do your projects, keep these concepts in your mind, right? Is there any way for me to optimize the code? I understand, right, for these projects that afterward it's not a student's project, it's not going to enterprise. You sometimes may not be able to see the difference. Sir, what's the difference? I run my code, only take 1 minute, I rerun, right? I just wait for 1 minute. But in the real industry, for enterprise level of applications, the units you're dealing with is not 1 minute. It probably can 1 hour or 1 day, right? It does make a huge difference on some of those good practice. ETL, ELT differences are just now already recap. Building an ETL pipeline, this is a skeleton. I didn't give it to you. So when you do your projects, you know how to follow, right? The structures. Details you have to fill in, right, in each of the portions. Cleaning, joining, and filtering, aggregations, pivoting, I think these are no-brainers. I think I won't go through. Filterings, simple Python functions. Aggregation, the same things. Combining the data, well, literally talk about joins, right? Yeah, you can do a data frame joins, or you can use the SQL join as well. I think Python does allow you to do so. Data quality is the basic stuff, right? Imputation, check for nonce, etc. I think these are simple SQL queries. I don't want to go through again. Star schema. This one, extra arrows. I go back to change this. There's the facts tables. This is a dimension table. You can see, right? If I want to get 3 dimensions, I just join them together. Otherwise, you have to get this one join with this one. There will be another one. You have to join, keep on joining, chaining. You have to join multiple different times. Like a nested joins. Keep this. This share with you, I think, how to connect with SQL databases, right? I know most of the time you're dealing with CSV from your local files, but inevitably, at the enterprise levels, all the information will be stored in a proper databases, be SQL or other type of databases, right? So how to connect to the external databases become one of the steps you guys need to know, right? In this course, of course, I can't deal with very complicated databases, right? I only share with you the SQL ones, but the rest should be similar. This is talk about some of the basic stats, right? We didn't spend time to talk about so-called how to build machine learning models. I think we only briefly go through with you, but in the lecture notes, I never share with you the details. So I only give you some simple describes the stats, right? To let you have a feel about the data. Iteration over data frames. Yeah, I think we do explain, right? For those of you who are traditional C++ Java programmers, you love to use the for loop, right? Iterating across all the elements one by one, and then explicitly doing the multiplications or divisions or summations. We're saying that if you could, don't use that. Use vectorizations. Matrix computation will be much faster compared to you enumerating through all the elements. I think the rest are very simple. Lambda functions. This one, important. I think we also, I know a good portion of you doesn't really have so-called programming backgrounds, right? So we do share and discuss. Why do you want to define a Python functions? Why can't I just write the scripts line by line, right? Why do I need to define a functions? Why? I know these are very primitive questions, yeah. But I do want to ask. Why? Why do I want to define functions in Python? For example, the example here, right? Why do I need to define square x and return x to the power of 2? Can't I just write a statement in my main functions every time I want to do a square? Y equal to x squared. That's about it. Why do I need to do these functions here? Two things. Of course, Python doesn't need to use the bracket. You just use the indentations, right? If I need to compute square x, can I just, in the main body of my programs, can I just write y equal to x multiplied with the x? Why I want to use this? Why I want to use this? Functioning, they are exactly the same. And this one seems to be more elegant, right? Because if I use this, I need to later on define square means what? Why do I need to add in extra steps? This is one. This is like this and this. Maintainabilities. So later on, when you want to change, if you've been doing the x squared for multiple different times, right? In a simple toy programming assignment, it's okay, right? 5 times, 10 times, Control F search throughout, change. But at the enterprise levels, you may use it 100 times. You may use it by multiple different people. When you do this, how can you guarantee you'll find all 500 times people using this and change all of them, no more, no less? You're testing people's patience, right? So, but if you use this, if you need to do any modifications, there's only one single place to change, which is here. I mean, I know there's a programming 101, but I do understand a good portion of you come from very different backgrounds, right? You may not touch on programming before, so I just still talk about this. All right. What's the time? Oh, 58. I have to speed up a bit. Transformations, okay. Lambda functions, okay. You guys spend some time looking into that. Distributed system basics. CAP. You got to know what is CAP. You got to know why we do CAP. You got to know what are the typical systems allow you to do CAPs. Is Hadoop a database? I think I asked the question before. Is the Hadoop a database? Then what is Hadoop? Distributed file systems. Architecturally, how does it look like? Not here. This is how Hadoop look like. Of course, this is not all. You got a name node, and you got a data node. Name node to do what? Does the name node store the data? It stores some data, but the data is not really the raw data. The data is the metadata. What do I mean by metadata? Nothing but a description about the data. Right? If there are 10 data sets stored across 3 different data nodes, I need to know what are the 10 data sets we're talking about. Maybe the first data set is actually the customer names. Second data set is transaction. Third data is about their credit rating. Fourth data is about operational risk rating, etc. Right? The name nodes will include those metadata as well as Where are those information stored? People will say, hey, sir, the information, of course, was stored in the Hadoop systems. But exactly which node? Each of the data node will not including all the 10 different tables, right? You only selectively store some. If you do not know what I'm talking about, ask questions now. Or ask question to GPT now. Because later on, after 8:30, both myself and GPT will become muted. Okay, and the same dataset can exist across multiple data nodes. Why? Because you want to do replications, duplications. So you maybe say, hey, sir, how come in the SQL databases you never talk about duplications? It come to Hadoop, you start to talk about duplication. And some more you talk about 3, replication factor 3. Means you need to duplicate the data set in 3 different locations, maybe across 3 different data nodes. Why? Yes. Fault tolerance. Why do we need to talk about fault? Because you're using distributed systems. Is distributed system more vulnerable? In general, yes. Why? Because each of the individual nodes are on, not say cheap, cheap sounds to be a very negative word, right? On ordinary commercial hardwares. Your laptop can be one of the data nodes compared to enterprise servers, right? Where you deploy your SQL databases. So it's slightly easier to fail. But how do you ensure most of the time is up? Or by use multiple different laptops together. Of course, laptop is oversimplification, right? They still use server machine. It's just that the server machine is the ordinary server, right? Not the very high-end ones, right? So the likelihood / the probability for the 3 ordinary hardware fail together will be low. If you want to push the robustness to be higher, you replicate 4 times, 5 times, 10 times. Right? But typically in Hadoop, the default one is 3. And also, the computation in Hadoop typically will be coined as map and reduce. What does map do? What does reduce do? I think we only have that lectures not very long ago, right? It's about 2 weeks ago, right before the recess. I won't repeat here. If you're unsure, spend time quickly to read. So after talking about Hadoop, we'll also briefly mention about Spark. What's one of the key differences between Hadoop and Spark? I mean, Spark is a big platform, right? You have many different components. But talk about Spark and Hadoop. One of the things people immediately think of is the computational speed. Spark in general, in terms of computation, is faster. I'm not talking about, I think Hadoop you use 100 CPU, Spark you use only 2. That's not a fair comparison, right? Spark in general is faster because the computation is done inside the memories. Whereas the Hadoop, most of the information, you're gonna want to take, okay, go ahead, it's okay. Whereas in Hadoop, the information are stored in hard disk. So every time you need to retrieve the information, you will involve a lot of I/O, means input and output. Read and write from a typical hard disk will be much slower compared to read and write into your RAMs. It's much slower. Okay, on-premise and on-cloud, I think we also discussed that in the most recent lectures. What are the major cloud service providers? I mean, still negotiating with them, ask them come over to give you guys lectures. Yeah. What are the major ones? Let me randomly pick up someone, right? This. No, don't worry. I know you know. Yeah. Yu Kun? Huh? He's sick today. Then Gosong, huh? Okay. Elaine. Yes. What are the... Give me a few names of typical cloud service providers. AWS, stuff for Amazon Web Services. Yeah? Name two more. Google Cloud, GCP. Microsoft Azure, right? Alibaba, Tencent, Huawei, many, right? A lot of them. What's the major benefits if I want to deploy my application on cloud? The contrast of that is to deploy my applications on premise. Class is cheap. Sometimes it's cheap, not always. The benefits, one of the benefits is the flexibilities. If you want to increase the storage space, if you want to have more CPUs, you don't need to go around to buy and install. You can just simply adjust the configurations. Two, you may have some pre-built function templates or services by those cloud service providers. For example, Google have Vertex AIs. Similarly, Microsoft, Alibaba, Tencent Cloud have something similar. So you don't need to hire a data scientist to build things from scratch. I'm not saying you can't, right? But there are certain available functions for you to call. You just need to pay per API call. How much is it? And you don't, sometimes, you don't need to so-called run IT teams in-house because all of them are cost, right? Maintain the server, maintain the databases, talk about renewal different software lessons. All this potentially will incur money, right? You can outsource to other people to do it for you. But why there's still people want to do things on premise means that they buy their own servers, install their own softwares, getting their own IT engineers to build their IT teams to store all this information. Why? There are still people who want to do things on premise. For security reasons, are we seeing that cloud service providers are not very safe? They're going to steal your data? Okay. Good point. Good point. In general, the cloud service provider can guarantee the uptimes 99.99. Some probably can go to the third digits. Yeah. But for bank, does it match to your risk tolerance levels? Maybe the bank need the whole system to be up 99.999 because that's the requirement imposed by the regulator for your core banking system. I'm not saying all the systems need to be up all the times, right? The core banking system, which allow people to pay the money, the payment systems, it can't afford to be down. Once it's down, the customer will complain. Maybe the customer business, I think, will be spoiled, right? Because they can't make the payments in times. There are sometimes be mismatch of the expectations. And also, in certain markets, there are laws, regulations, impose the data have to be stay in that countries. Indonesia, for example. And if the cloud server is remotely in some other places, too bad. You breach the rules and regulations. You can't do things in that way, right? There are other considerations. I think all of them have been documented very clearly in the notes. I don't want to go through it again. The reason why I'm doing a quick recap is to make sure the core concepts are properly registered in your mind. Otherwise, you keep on talking. You guys don't know where the focus it is, right? And some of you probably, it's relatively new concepts. Some of you come from business accounting backgrounds, right? This really can be considered as a new and dry things probably. Yeah. Data analytics basics, I think I will not spend too much effort here. This is not a class talk about machine learning, how to build models. Yeah, we also spend enough time, half a lecture to talk about this. Basic programming tips, I think just now we briefly go through. Yeah, so I will stop here, and if, next 20 minutes, you guys take a break, right? Go toilets, get your waters, make sure you charge your laptops, and around 8:30, we're going to begin our quiz. Of course, before that, I need to do the attendance marking first, right? Put a matriculation card, I think, in front of you so that I know who you are, right? Later on, I don't want to slow you down by asking you give me the card, right? I have to quickly, I have to spend some efforts to take it from your bag. Put it there. Around 8:30, please return back to the lecture theaters. We're going to prepare our quiz. Don't worry, we're not going to start our class earlier. I'll be thinking to save some time, right? If you guys are around, so when you call your names, I just take for you, huh? Anteyon, okay. 新月，小梦 okay. 伟毅 yes, I saw her just now. 浩南 Charming you, okay. 邓涵 yes, I saw you. Dylan, 丁轩 一飞，杜一飞 ，OK。婷婷 ，Lin yes。奕晨，奕晨 ，Barcelona OK。天意 ，Some of you really I feel like I'm seeing you for the first time. No offense, it's just that I think. This is the first time I have all the checks in a row. You guys saw the, God of Gambler before, like Royal Flush. Yeah. 合肥 OK. 雨欣宝一克飞 Restaurant 啊，文琴 Brandon 西月西月胡西月 OK 燕如陈一君慧伟康伟康 calling twice OK 宇坤宇坤 is the one calling sick today, right? Oh 一伟雍义 Ivan 子萌申彤 Marcus 博涵蓝宇蓝宇蓝宇 is he here today? Do you know? 李蓝宇 Normal, I'll come back to check with later. 天宇梁波子珊瑞奇 Don't worry, we're not start the class yet. I just want to save some time, right? 瑞奇 Okay. 一航一航一航 later, do you mind when I later check your matriculation card, you take away your mask for 5 seconds, can No, not now. Later on, right? You wear, yeah. When I check your matriculation card, I think I need you to remove the mask. 泽凯 Okay. 瑞瑶伟帝俊伟中阳努波亚苏金航 Pambo, yes, I just saw you. Junwen, Junwen. Hao Wen. Shen Yang. Si Yu. Okay. Yuan Peng. Sumida, yes. Junhen, Tan Junhen. Li Ren. Now the thing, you know the data quality issue, right? Sometimes your given name has been highlighted. Sometimes your surname has been highlighted. I don't know, right? Or maybe it's always given name, not the surnames. Sometimes I have a difficulty to recognize which one is. Tanya, yes. Calista, yes, as well. Okay. Kampi. Huan Qin. Always on mask, okay. Junya. Paga. Okay. Binyu. Wenbin. Zhehan. Yi Guo. Hao Fei. Li Wen. Bo Wen. Zhao Jun. Jian Yi. Xiao Ran. Yao Yao, yes. Lu Yang. Pei Hong. Ziyu. Bo Wen. Dan Meng. Jin Tai. Jin Tian. Xiao Xu. Kang Rui. Jun Yi. Li Wei. Yan Zhi.质朴。自然。Okay. 文杰。We have two more. One has really notified me his own MC. The other one, where is he? Li Lanyu. Is he here today? For those of you come from the same projects, do you know if he here today? If not, he will be right away 0. I'll take it as a no. Anyway, he can't log in anyway, right? If he's not here today. He can't log in, right? Yeah. Right away 0. Calling twice, Lan Yu. Calling 3 times, Lan Yu. Okay. 2 persons are not here today. All right, I think we're going to take another 5 minutes for you to be a break. Around 8:35, we're going to begin our quiz. For those students, right, if you bring your actual matriculation card, put it there next to you. If you wear the mask, you can continue to wear, but when I approach you, take out the card, please lower down your mask for me to make sure you are who you are, right? I mean, I trust you because I already do validations, but that's the protocol I need to follow. It's a MCQ plus true and false type of questions. 25 questions. You have been given 30 minutes. You can, when the quiz starts, internet will be blocked, right? So you can't use the internet. Even if there's a so-called a secretive way for you to use the internet, please do not use that. Internet is forbidden. You can't use any AI tools, but you can refer to the lecture notes or your own notes stored in your laptops. You can't use the phone, communicate with each other. It's an independent task. It's an independent quiz. 70 minutes. For those of you, if you encounter any technical problems, raise your hands. We do have the specialists, I think, from our teaching center come to assist us, right? All the questions in the quiz will be randomized in sequence, right? So don't try to borrow the experiences from your neighbors, right? It will be very different. And I think that's about it. Any other question from you guys? Oh, MCQ is really MCQ, huh? Some of the so-called questions, I do expect more than one answers, right? Not all, a good portion of that. True and false is only true and false, right? It won't be both true and false, either one. Questions from you? You got about 5 more minutes to prepare, right? 2 last-minute revisions. I will give you the passcode soon. Oh, really? So all of you have downloaded Exemplify? Have you? In the backends, I think there are. You want to see something? Yeah.
No, ask them to download the exam file on Exemplify.
Oh.
Ask them to download the exam file.
Let me. Do you have the name here? I want to. Yeah. In the backends, there are 10 of you have not downloaded the Exemplify applications yet. You don't want to waste your time on that. The exam file, huh? Okay. So, okay. After you download the Exemplify applications, you also need to download the quiz file as well. There are 10 of you have not done so yet. I mean, we're trying to get your names out. It's okay. Yeah, you save the pictures there later on. Yeah. Let me see, 昆宇、小旭、云琴、冰雨、燕涵、子昂、宇坤. All of you have not downloaded the quiz file yet. If your name has been mentioned, please go to the link I gave it to you. Download the QF5214 quiz 1 exam files, because you need to load that later on after I give you the passcode. Six more on the go.
But you said only 2 absentee, right?
Only 2 absentees.
But did you, the mentioned names are here? Any of them?
Let me check. But they can't remote attend, right? But unless people pass them the code. If the people pass them the code, can they use it? Huh? They shouldn't pass the code, right? Yeah, they can't. There's one Li Lan Yu. Let me see. No. Then the other one is. Let me see. He sent me the emails. Fong Yu Kun.
Yeah.
Yeah, the last
This
one,
one
right?
fine.
Yeah.
The other one?
Then you got, let me see, 6 more, right?
1, 2, 3, 4,
5, 6, 6. I don't know. Are you in the back end? I think you're still not downloaded the quiz file yet. Can I have the names? Let me. Yukun, you around? No, there's. Oh, how come they have two? Kun Yu Yukun. Never mind. Xiao Su. Xiao Su. Are you around? Yu Qin. Why there? Wu Bingyu. Not here.
download your exam.
Can you download exams? You downloaded. Okay. Liu Yanhan.
Oh, drop the course.
Or drop the course.
Okay,
But how come still appear here?
No.
Ziang. Drop the course as well. Oh, but it's appear here. Okay. Let's give them another. Okay. All right. I'll share with you the exam code, but you are not allowed to share with those people who are not coming to here, right? If I notice they are taking exam remotely, there must be some information leakage. Both people will be implicated because this is an on-site quiz. I repeat this message again. I will share with you the exam code, but you are not allowed to use your phone to share the exam code to people who are not coming here to take the exam here today. If that happens, both persons will be implicated. See 2 times already, and it's been recorded. Please, when things happen, please do not say, I never mentioned clearly. If you need me to see in other language, I won't do it. I can't, okay? All right, I'll put down the exam code. It's the one I said last time, right? Okay, no, I have that. Okay. Put on the screen better, right? Okay, I write here. You may now enter the passcode to take the exams. Any problem, raise your hands. We'll be going around to support you. You approximately have another 5 more minutes, right? Please watch over your times.